Hi, today I want to talk about soft edges. I have this soft sort of object that I've created here. It's a three-dimensional object, and you can kind of see through the middle of it. It's actually inside of it, or it's actually a sphere. The vertices of these two things that we're looking at right now are exactly the same. The difference is, of course, the shader program. So how did we achieve this? Well, if I walk around here, you can see I can always see through the middle of that, right? And it has that ring kind of halfway through. And so when I'm standing here, the light, can come straight through the middle, right? It can go through this top part, right? Go through the bottom part, but halfway in between here, it it strikes something. And so the shader program needs to know the angle that these rays are going through this sphere. I've drawn a little diagram over here. So in the straight through case, the normal, which points out from the center of the sphere, is the same direction as from this point towards my eye, right? And up here, right, at the very edge of the sphere, this normal is perpendicular. And we know that the dot product of perpendicular vectors is 0. And in between, we form some angle. And the dot product is the cosine of that angle. And then with a little bit of trig, applying Pythagorean's theorem, if we have a sphere of radius 1, then this leg will be cosine theta in length. And if we wanted to know what the length of this is, which would tell us how far up and down we are kind of in this sphere when we're looking at it, from this direction, right? It'd just be this square root here. So we can put that together into a shader program. Let's look at some code here. This first part here gets the view position, which is, I like to think of it as axes that are centered at my face, right? And so we have z coming out from me and x going to the right, y going up. And that view position can tell us basically what angle the point is at, and so we can get that right here, right? And we have a normal coming from the geometry, right? And then we calculate the position in the same way. And then we're passing both of these as varyings to the fragment shader. And so the fragment shader can do that math that we just discussed with the square root and eventually set this frag color. Now, this vertex shader part of the program, right, it only runs once for each vertex, right? And this fragment shader runs for every single pixel. So what would happen if we were to put this code up there? It would run a lot more efficiently, right? So what I have here is another version of the code where I've simply, moved that code, out of the fragment shader. Now the fragment shader is very simple. Let's take a look at what this produces. It's not nearly as clean, right? There's some trade-off that we have between doing all of the work in the vertex shader, which gives us this kind of not very round circle-y thing, versus doing all of the work, doing the coloring work in the fragment shader. We get a much cleaner circle. So transparency, what we've employed here, is one way to make a softer edge. And a little bit of trig can make this kind of interesting effect. And that, my friends, is essentially it.